Hello, everyone. After a pretty long break, we come back to webinars. I'd like to welcome you to our webinar about event-driven communication in a microservice architecture. So good afternoon, good morning, or evening, depends on where you are. Before we start the main webinar, I wanted to take advantage of the opportunity to have plenty of technology enthusiasts in here and invite you right away to our next event that will be held next week. I think about CTO roundtable that will be organized during one day of Amsterdam FinTech Week on the 8th of June. Our session will be about the factors that impact digital transformation in FinTech. The event will be hosted by our general manager for the Netherlands, Herbert. He will be joined by Jaap Borsma, the CTO at Amsterdam Trade Bank, and Steve Cook, CTO at Form 3. Together, they will discuss what success means in FinTech and what is the future of FinTech in terms of technology. If that sounds interesting, feel free to read more about the event using the link that just appeared on the chat. For all of you who will be patient enough, we also prepared a little gift that will be unveiled at the end of today's event. But let's back to today's webinar. Why that topic? Microservices have become more and more popular, and communication among them is a crucial and non-trivial aspect. It's part of our expertise because our company specializes in building custom web applications based on PHP and node.js on the backend side and React.js on the front end. We've already done this webinar in Polish, and seeing the interest, we decided to share this knowledge and experience with the whole world, this time in English. This webinar is led by my friend Paweł, who is a lead backend developer with over 10 years of experience. We have also Mariusz Richait on board, who will be answering your questions on the chat. If you have any questions, feel free to ask at any time. There is a special Q&A section on the bottom bar, so please use it. You can do it on the chat as well, but it's harder to catch and you might miss it. One more important thing, the default settings on the chat let messages only to the panelists. Please change it to panelists and attendees to avoid issues with lack of answers or discussion below your question. I think that's all from my side. So without further ado, I'd like to hand voice over to Paweł.
So hello, everyone. I'm happy to welcome you to today's webinar dedicated to the topic of event-based communication in microservice architecture. So probably many of you have heard about this type of architecture. Some might even consider using it in their projects, but you weren't sure how to get started with it, or like what difficulties you might encounter. So I hope that after listening to today's presentation, I will dispel your doubts regarding this topic. And when you are again faced with the choice related to architecture, it will be easier for you to reach for the one related to the microservices. So what topics we'll cover in this presentation? Firstly, I will talk about the types of communication we can use in the microservice architecture. Then we'll move to the popular patterns, and I will tell about the challenges that we can face during the development. And at the end, I will go over the short summary, and we'll move to the Q&A section. So what's the microservice architecture? So according to the fairly general definition, it's a way of designing applications as a group of services that we can deploy independently of other services, and we divide services into groups corresponding to a specific business action and logic. In an ideal world, each microservice, like we would have the single development team that could like work on. So now, when we know like the definition of microservices, microservice architecture, let's assume that we transitioned from the monolith to microservices. So at this point, we have like services groups and we need to communicate them somehow with each other. So we can distinguish like two basic types of communication: the synchronous one and the asynchronous one. So synchronous one is the typical request response one, where the calling service waits until it receives a response. For the asynchronous one, it's event or message based, where the caller service emits an event and process subsequent requests without waiting for the response. Typically, for the protocols, for the synchronous one, we'll use the HTTP protocol together with some kind of REST API. For the asynchronous one, we usually use some kind of event broker like Apache Kafka, Redis PubSub, RabbitMQ, Amazon SNS. So the advantages for these different types of communication. So for the synchronous one, it's definitely the ease of use that comes from the text-based HTTP protocol, which also means that the problem tracking is definitely simpler, and we will get like the immediate response during the request cycle. For the asynchronous one, we have the loose coupling, improved responsiveness, as like we don't wait for the responses, and we can process like the subsequent ones, and it's easier to handle the failures in the system. For the disadvantages, like for the synchronous, the service is blocked while waiting for a response. And during the call chain of requests, like all services must be available to get the response. Also, broadcasting is not possible. For the asynchronous one, we are somewhat like heavily relying on the event broker. The communication becomes complicated due to the nature of the asynchronous communication, which also means that backtracking can be challenging. But like we split the monolith, we know the basic communication types and what next. Quickly, we can notice that the things that were a problem before have become a little more complicated. So one obvious thing that would be the data retrieval. So after we split our app into various services, each of them can contain their own database. So unlike in the monolith app, we can't easily join the data between tables using the single database. Now we need to fetch the bits of data by ourselves from various sources. And luckily for us, we can use some help of programming patterns, especially useful like in this case when we want to fetch like data from different sources. It will be the API composition. So this pattern allows us to combine responses from different services where responsibility of joining data falls on one specific service. Usually it's the backend for frontend service or the gateway. How it works, like in a nutshell, we have the API composer that queries the individual services and combines data that needs to be returned. It works well if we require a response immediately. So, for example, in some kind of like e-commerce system, we'll have the search results. So we want the data to be returned for the given request. And now, when we know what communication types and what we can use and how to fetch the data from various sources on services, we can take a moment to think how to communicate microservices together to fulfill the business logic. So for that one, we can use the pattern called the orchestration. In this pattern, we have a central point that manages the interactions between the services. There is one service delegated for this purpose with the knowledge about all other services in the system. So orchestrator queries specific services in a given order to achieve the business logic. It's especially useful if we require some data from one service in another. Communication is simple and mostly synchronous. But the problem here is that the susceptibility to the failures. So if one service fail, the others will also stop working. Additionally, we have the centralization of knowledge that creates the strong dependencies, which can lead to the distributed monolith. And that's something that we would like to avoid to preserve the flexibility of our application. Knowing that, like previous solutions, we want to put the emphasis on the decentralized management, loose coupling, and the flexibility. So to achieve that, we can use event-based asynchronous communication. So moving from synchronous to asynchronous communication, like we should get familiar with the publish-subscribe pattern. It enables the exchange of events or messages between publishing services and subscribers of specific message on the event or the message bus. The sender doesn't know like how many recipients there are, and the so-called event broker deals with the delivery of messages over the bus to the specific subscribers. Additionally, using this pattern, we gained the ability to send events to many recipients at the same time. So we switched from the synchronous to asynchronous communication, and now we're using the event-based one. And now we need to rethink the way we coordinate our business operations. One of the popular patterns addressing the problem of distributed logic execution is called choreography. In this scenario, all services listen on the event bus only for specified messages. So upon receiving such a message, they run internal processes to handle the events. So at the end of the event processing, service can broadcast a new event back to the message bus, which allows other services to continue the processing and react to the to send events that are like published on the event bus. So in this configuration, we ditched the central point of business process management, focusing like on the better service isolation, providing greater flexibility for changes and reducing the risk of failure of the entire system. And when it comes to the failures in the system, what can be done to ensure the data consistency in the application? So now we should try to implement the error-proof transactions that span over the multiple services. And to achieve that, we can use the choreography-based sagas. Saga is a sequence of local transactions performed by specific services in order to achieve a certain business logic. The first transaction in Saga is initiated by an external request sent to the system, and each subsequent step is triggered by an event published after the completion of the previous local transaction. And as a side note, like in the given example, we still have the event bus, but for the sake of the simplicity, I just removed it to make it a little bit clearer. So this is like the example of some process in the e-commerce system. And one of unique feature that of the Saga is the ability to execute compensation transactions, which allow us to undo the changes that were made by previously executed local transactions. And that's the key feature that allow us to ensure the data consistency in the microservice architecture. So in this example, when we have the ordering process, so we can see that it started from some kind of request from our app that went to the cart service. Then we notified the order service about that fact. And we, as we want to buy something, we are locking the quantity of some product we want to order in product service catalog. And then we move to the payment service to handle the payment. And then something happens. So the process like broke. Some services were like unavailable, and now we are in a state where we locked our product in catalog service, and this is like the place where the Saga like shines, because now we have the opportunity to execute the compensation transactions. So from the payment service, we can inform the product catalog service that something went wrong, and we should like unlock the product that we locked for the processing. From there, we can inform the order service about the fact, and to the first one, to the cart service, to compensate all the transactions that were executed during this during handling of the business logic. What other challenges we can face during the development, and how we can handle them when it comes to the event-based communication? So continuing the topic of errors in the system, let's focus for a bit on a transient system faults. This type of errors are quite common, especially for like large cloud-based applications, where, for example, like some services are like not responding, like, or we have connection problems that are quite common. So to cope with that type of problems, we could use probably the most widely used pattern called the retry. Retries are designed to deal with the situations where for a short period of time, some system component is down or becomes unresponsive. And after detecting this failure, it can automatically retry the operation. In event-based communication using the event broker, usually it goes like that. We have the producer that emits an event on the message to the exchange, to the exchange, where event broker puts the message into the processing queue. There, consumers can pick the message and process it. And if we fail to process that event, we can send it back to the exchange, where we'll put it to the temporary retry queue for a given amount of time. Like it depends, like how long we want to be there. Then automatically it's moved back to the processing queue, where the consumer will have the opportunity to process it again, and this time, if we process it successfully, we will continue with normal business flow. So how like that was the transient system faults, and how to deal with the non-transient failures. So the key thing here, like regarding this type of issues, is to limit the impact of such failure on our entire application. So to handle that cases, we can use the pattern called circuit breaker. It allows us to react on errors and gives the immediate response to a failure. This happens without the need to wait for the propagation of information about failure itself or the further timeouts, limiting the scale of the problem in our application. The easiest way to implement this pattern is to implement it as some kind of proxy for a specific functionality. The circuit breaker monitors the number of unsuccessful calls, and after exceeding a certain limit, it will cut off the possibility of making subsequent ones. When circuit breaker opens, it will immediately return an information about the failure. And in the world of the events, like we can react to number of messages or events in the queue, the number of retries, or the amount of the rejected ones. And as I mentioned, like we have like a few states for the circuit breaker: the closed one, the open, and half open one. So for the closed one, all calls requests are forwarded. It's the normal flow. Sometimes if something bad happens, like if we fail to call some service, and will fall under the threshold, we still can use the retry pattern, but it's still the normal flow. However, if we fall like on the threshold, circuit breaker will automatically open, and we'll switch to the fail fast mode, where we don't wait for example, for the timeouts or the response about the failure. We'll return the failure information like immediately, and we'll also activate the timer. So after the time runs out, we're moving to the half open state, where we'll try to forward like one call, one request, to check if the problem is still persisting in the system. If so, then we'll reset the timeout and we'll move back to the, we'll reset the timer and we'll move back to the open state. And if that one goes like successfully, we'll move from the half open state to the closed one and to the normal flow. For the other changes, along with the change of the architecture, like from the monolithic one to microservice one, the way of collecting important metrics also changes. Information about the errors is scattered through the entire system, and asynchronous communication makes it even more difficult to gather and analyze. So we can get by with the help of distributed tracing, where we can use the tracking ID added to all events related to the execution of a specific business process. And this way we can easily monitor data flow in the system. Usually, we generate this unique tracking ID somewhere at the entry point of our application, successfully adding it to all events emitted through the business logic handling cycle. And knowing that we have like the same tracking ID through the whole cycle, we'll have like logs from all of our microservices stored with this extra piece of information that we can easily extract if we want to. We just need to filter the records for the specific tracking ID and order them using the timestamps. This way, with the help of the tracking ID, we can assemble the so-called combined logs file, which normally would be the tedious work. But with the tracking ID, this make it a lot like easier, and we can assemble them automatically. So yeah, that would be all for the challenges and like popular topics. And moving to the summary of the event-based communication. Just like any solution, it has its advantages and disadvantages. For the advantages, this type of communication is non-blocking and it's asynchronous by the nature. We are loosening the dependencies in the system, which also make the scalability easier, and also we have the opportunity to handle better the failures in the system, and we have the possibility of notifying the many subsystems simultaneously. For the disadvantages, communication becomes a little bit more difficult to track, especially like if we don't implement the tracking ID. Looking through the error logs is always time-consuming and hard. We become somewhat dependent on the event broker, and it requires additional work to implement the failover solution. That's something that we need to think about when we start new project, and we need to implement all those features. But which type of communication should you choose? Like it largely depends on the problem we have to solve. There are situations in which given type of communication will work better than others. But fortunately, we have the opportunity of using both types of communication in our application. We can use the choreography orchestration hybrid, where, for example, we can use the search functionality with the synchronous communication within our app, and the order processing could be done asynchronously in the background. And yeah, that would be all for this presentation. But if you don't want to miss the upcoming TSH webinars and other events, make sure to subscribe to Tech Keeper's Guide, our bi-weekly newsletter for ambitious tech leaders. Also, last year, we published the State of Microservices 2020 report based on a microservice survey conducted among like over 600 tech leaders from all over the world, with one goal, to find out how developers really build their microservices. You will find a lot of interesting insights there, with the commentaries written by the experts from DAZN, CopperPress, or Vercel. So if you want, you can download it or read it online. So now we'll move to the Q&A section. And let me check the Q&A panel, but I'm not sure. I don't see any questions. Okay, so if someone want to ask some questions, like please don't hesitate. Okay, so like if you have like no other questions, like we can conduct the presentation. So thank you all for your attendance.
Okay, so apparently there is some question. So let's wait for a while. There we have one question. Paweł, can you?
Okay, but I
have a question, but there's no question.
But like we're not sure like what the question is.
Yeah.
Okay.
Okay, so apparently there are no questions. So thanks to Paweł for his great presentation. And okay, just writing it out. So Paweł, can you come back for a while and let's give and who? I'm not sure we are pronouncing it correctly, but let's wait for a while.
Okay, so I can see like one question. If you talk about choosing the event-driven or synchronous-based on your requirement, then how do we decide what parameters to consider to make the choice between the two? Basically, the synchronous communication, it's especially useful, like, but it's required to get the response immediately. So if you want in the response to get data, then that's probably the only option for us to get it during the call, and all other communication that can handle in the background. So order processing, propagation of some data, exchanging the data between the services to make them in sync. It could be done using the event-based one, so the asynchronous. So I know, like also like reacting to the payments, like all the stuff that can be done like in the background behind the scenes, and when the user like doesn't require the response immediately. Is there any package you suggest to handle with the service it crashed? It probably depends like on the solution. Usually, if that's not something really complicated, we just do it by ourselves. So we handle them through our code. And yeah, like unfortunately, I can really suggest one. It really depends on the problem and on the scale. And the QA section, do we need to follow a specific pattern while implementing the circuit breaker? Well, the circuit breaker is like one of the patterns, and it also involves the retry one. So yeah, like this one also like depends like how we want to solve it. But the circuit breaker is the pattern itself. So there's some documentation and info that we can use to implement it. And yeah, like if someone want to ask some questions like later on after the presentation, please let us know, and of course I will try to response also to the emails. I want to go for microservice architecture. Well, like it, as like at the beginning of the presentation, if we put the emphasis, if we are putting the emphasis to the scalability, the flexibility of our application, and we want to have the decentralized management of our app. That would be some of the clues when we should consider this architecture. So if we are like not sure which type of technology we want to use in our app, or we foresee like in some future that this might change, then it would be the good opportunity to do it using other patterns like hexagonal or something that would also help us with the microservices. And yeah, that would be it. And we have like another question, like when to synchronize asynchronous pattern. I believe that I responded for that one in the from the chat. So synchronous one, definitely when we want to get the data, the response immediately from our app. And asynchronous one, like it depends like what problem we want to solve, but definitely like something processed in the background, or like when we want to notify multiple services about some kind of changes, or we want to sync the state between different microservices. One of the examples, like as mentioned, we react to the for example, payment events, the user change events. We synchronize the data between many of our microservices. Okay, I think that would be it.
I believe we answered all questions. Thanks to Paweł for his great presentation, and for Mariusz for helping with questions on the chat. Thanks for your time, participation, and your interesting questions. Now it's time for the gift I promised at the beginning. If the CTO roundtable during Amsterdam FinTech Week on June 8th sounds good to you, and you want to join us, we wanted to give you a promo code that entitles you to get a free pass for the whole day of Amsterdam FinTech Week. To claim this, please use the link that just appeared on the chat. You can see it on my screen as well. When choosing the ticket for June the 8th, please paste the promo code that appeared on the chat and my screen. We hope to see many of you during the day. And last but not least, we will be back to you soon with more information about the next webinars, because we wanted to do them more often than we recently did. See you on them, and bye.